Hello, let's continue our Sudoku adventure with Italics Adventure by Emphyrio. So this continues our zipper theme week. Hope you're enjoying it. We've been doing zipper puzzles all week. So let's go over the rules. But before we do, I do want to mention that this puzzle, I'm told, is a little bit on the harder side. If you have to spot certain things, this is just what I'm told. You have to spot certain things or you're going to have a hard time. But 3 of our testers said it was a very cool puzzle. And once you spot it, it flows nicely. So take that as you will. You can always reference my video if you get stuck. And so let's go over the rules. So we have normal 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these lavender lines in the grid. These are even length zipper lines. Both of them are even length. So what that means is you take the center, which is marked with a little square here. Cells that are equidistant from the center sum to the same amount as each other. So it's really hard to describe, but you pair up the cells that are equidistant from the center, like these, and these. Those pairs of cells, you take their sum. That sum is going to be the same for the whole line. So let's go over an example. If this was 3 and 5, that sums to 8. So now these have to sum to 8. We could do 4 and 4, and these have to sum to 8. We could do 2 and 6, right? You just move along. These sum to 8 and these sum to 8. So once you figure out what the sum is of any of these pairs, the rest of the pairs must be the same sum, is another way to put that. That's true here as well. These, and these all sum to the same amount. Okay, and we also have killer cages in the grid. Those are these cells surrounded by dotted lines. So like these here, and they sum to the value on the top left. So these sum to 5, these sum to 9, these sum to 8, etc. And those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Well, 5 cages are either 1, 4, or 2, 3, so I like to put 1, 2, 3, 4 into them to remind myself of that. Okay, there's a little trick with two cell killer cages that sum to consecutive amounts. This actually works in 9x9 as well. We could also use the outies here. But I want to show you what I mean, just so that you know this, because it's very handy in killer puzzles. So they're always going to reduce options from each other. I'm not sure exactly why. I'm sure there's some mathematical proof, but it always happens. And you can just walk through the cases. So 9 is only ever 4 plus 5 or 3 plus 6. 8 is always 3 plus 5 or 2 plus 6. Now, what you want to do is you want to look at the 3-5 case on this 8. And you notice, because the 2-6, this can't have a 2 in it. So it's the 3-5 case that's interesting, because both 3 and 5 are available by the 9. And so if this was actually 3-5, these couldn't be 3-5, and they'd add to 10, right? That doesn't work. The 9 needs a 3 or a 5 in it, which means this can't be 3 plus 5. So it's 2 plus 6. And then this ends up 4 plus 5. Now, the other way we could see that is this box adds to 21, and then 8 plus 9 is 17. So to get from 17 to 21, we need 4 more. So these must add to 4. So this is a 1-3 pair. And now 3 is gone from the 8, can't be 3-5, so it has to be 2-6. And then the remaining 2 digits, are 4 and 5 to get 9. So the same result happens. Okay. I'm going to mark that 2 and 6 end up on this line. Right, so we have this 4-5 pair. So this is another neat trick with zipper lines that probably Emphyrio is intending us to notice. So this is a cool idea. So let's take it one at a time. 1 is definitely on this line somewhere. So what is the maximum sum that any pair could have? Right, it's going to be 7. Because we can do 1 plus 6. We can't add to more than 7 because we know there's a 1 somewhere on this line. But we also know there's a 6 somewhere on this line. So the minimum we could add to is also 7. Because if there's a 6 somewhere here, the lowest it can pair up with is a 1. So that means the sum must be 7. There's no other choice. Otherwise, we wouldn't be able to put the 1 or the 6 down here. If it was less than 7, we couldn't put the 6 on here. If it was more than 7, we couldn't put the 1 on here. I mean, we must do both. So these add to 7. Okay, I'm thinking we know we know a lot about these 2 rows, so let's do that next. This is going to be an outies thing, similar to what we did in this box, actually. So these add to 7, these add to 7, these add to 7, right? So it's 7 times 4. These add to 28. And then this adds to 9. So if we add 28 and 9, we get 37. Now, what do these two rows in total add to? Let me put the green back. In total, these add to 42 because there's two rows. Each row adds to 21. 1 through 6 adds to 21. So 2 rows adds to 42. And we just removed, what did I say, 37 from that? So to get from 37 to 42, these two cells need to add to 5, which means this is also for 1, 2, 3, 4. But we can do more than that because we know these two are the same digit. I'm going to make those green. Because if these add to 5 and these add to 5, they share this in common. These have to be the same in order for that to be true. So I'm going to pair up green with purple because this cage now doesn't have green in it. So it cannot be the green-purple cage. We're going to make it the blue-orange cage. We don't know which is low or high, but it doesn't matter. So what we've learned is these two are different digits. And that leads us right into here. We can do the same sum. And we can see what that tells us. So there's 5 of these here. I will point out that we already know that there must be a 5 and a 6 on both sides. So our minimum sum is already 7. But and then there has to be a 1 or a 2 on the other side. So our minimum sum with 5, 6. So with the 6, we're going to be pairing up at best with a 2. Like if this was a 1, the 2 needs a pair. Yeah, so we need to add to at least 7. And I think we can add to at most 8 because we're going to have a 2 up here. Or a 1, right? If it was a 1, it would force it to be 7. So that's going to be multiplied by 5. So we're either 35 or 40. This adds to 35 or 40. Now 40 I can already see doesn't work. Because if this added to 40, then these two would need to both be 1 in order to get to 42. And we know they're different. We just proved they're different. So this adds to 35. This is also 7. And because we know there's a 6, interesting. We know there's a 6 on both sides. That means there's also a 1 on both sides. Wow, okay. So that means neither of these can be a 1, which means neither of these is a 4, which means that's not a 1 either. Interesting. So all of these pair up, all these pairs add to 7. That's really interesting. What else can we do with that? Oh, well, okay, we can do the outies, right? So these add to 35 then. So 40 to get to 42 from 35, we need 7 more. So yeah, this has to be 3 plus 4. So these actually aren't 2 either. So these are a 1, 2, and this is a 3, 4. Okay. Neat. So these add to 7. Okay, well, 3 plus 4 is 7. But these can't be, this can't be a 3, 4. Interesting. This whole column is 1, 2, 5, 6. That interesting. So that pairs up with a 1, 2, 5, 6. Oh, I suppose this is a 1, 2 pair. This can't be 1 or 2, so this is from 3, 4, 5, 6 for what it's worth. Okay, is there more I can do with this? Well, these add to 7, so this is either 1 plus 6 or 3 plus 4. This is a 1, 2, 5, 6 as well. Okay, what am I missing about this? Oh, there's a virtual 1, 3 pair between these two. Because this needs a 1 or a 3 in it, and this needs a 1 or a 3 in it. So we can't have more of those 1, 3. So this isn't a 3. I feel like there's more to this. Okay, so these are going to be every 1, 2, 5, 6 pair along with a single 3, 4 pair. Does that help me? This is 1, 2, 5, 6. It can't be 3 or 4. That makes that 1, 2, 5, 6. Interesting. Wait. The blue 3, 4 is somewhere in here, which means the green 3, 4 is somewhere in here, which means the green 3, 4 is not in the 9 cage, which means the green 3, 4 has to be 3. Sorry, it has to be 4, because only the 4 is excluded. Yeah, none of these can be 4. But we know that one of these is green. Because one of these is blue. Interesting. Oh, that's cool. Okay, one of these is blue, which means one of these is green. So the green can't be 4. So the green is 3. So blue is 4. That's 1. That's 2. Very cool. I'm not sure if there was an easier way to see that, but that was a cool way to see it. That's 1 and 3 then. 3 plus 4 is 7. That's 5 and 4. That's not a 4. That's not a 1 or 2. We get a 5-6 pair here. That might be useful. Neither of these are 1, which means neither of them are 6. This can't be 2, which means that can't be 5. We already kind of did that. Okay, 2 plus 6. So 2 plus 5 or 6 plus 1. That's never 6. 2-6 pair sees over. That's a 5. That's a 2. That's a 6. 2 plus 5. That's a 1. Okay, that works out. This is just a pair now. It's 1 and 2. We can fill them. 2 gives 5. 1 gets 6. That's 2 and 6. That's a 1. Looks like we cracked the puzzle. Though hopefully I'm not speaking too soon. It seems almost done. We need a 3 and a 4 down here. Okay, what does this box need? It needs 4 and 6. 6 would go with 1. Okay, and that can't be a 1, right? So this is 4 and 3. That's 6 and 1. We get the 4 and 3 here. These are the other 2 5 that go that way. We need a 2, we need a 6, and then we need a 3 and a 4 to go that way, and we're done. All right. Well, it took a little bit of time, but that was neat. There were some really neat deductions in this puzzle. Definitely on the harder side, just because of the number of deductions you had to make. But a lot of good use of outies. We had outies in this box. We had outies in these rows. We had outies in these rows. That really worked very well together. Also, twice we used the fact that because you're forcing some digit onto here, it changes the min-max equation. Forcing both of these to end up being 7 in a pretty cool way. So really enjoyed that. Thanks, Emphyrio. Hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.